Good morning to all of you. I hope I am audible and my screen is visible to all of you. So before starting today's class, let me just give you a brief recap of what we have done in the last lecture. In the last lecture, we have solved few problems related to Dalembert's principle. So in today's class also, we will be solving few more problems related to Dalembert's principle. And the next problem that we will be going to discuss in today's class is this problem. What is this problem? Two blocks of masses m1 and m2 are connected by a flexible but inextensible string as shown in the figure. Full stop. Assuming coefficient of friction between block m1 and the horizontal surface to be mu. Full stop. Find the acceleration of masses and tension in the string. Assume mass m1 is equal to 10 kg, mass m2 is equal to 5 kg and coefficient of friction mu is equal to 0.25. Again I am reading out the question for you. The question says two blocks of masses m1 and m2 are connected by a flexible but inextensible string as shown in the figure. Assuming coefficient of friction between block m1 and the horizontal surface to be mu, full stop, find the acceleration of masses and tension in the string. Assume m1 equal to 10 kg and m2 equal to 5 kg and coefficient of friction mu is equal to 0.25, and this is the diagram given to you in this problem. So according to this diagram, there are two masses, mass m1 kept on horizontal rough surface and mass m2 is held vertically by a string. Both the block mass m1 and mass m2 are connected by a common string through this pulley, and this arrowhead represent the direction of acceleration of mass m1 and this arrowhead A represent direction of acceleration of mass m2. That means from this arrowhead symbol of A, it is clear that mass m1 is moving in this direction and mass m2 is moving in this direction. Okay, what we need to find out? We need to find out acceleration of the masses and tension in the string. Since only one string is used between the block mass m1 and mass m2, so the tension in the string, say it is denoted by symbol T. This is the tension which the block mass m1 will be exerted on this string, and say suppose this is the tension T which block mass m2 will exert on this string. This we need to find out in the problem. And secondly, we need to find out acceleration of the two masses. Here acceleration of both the two masses will be same. Why same? Because both the two masses are connected by a common string. If mass m2 is moving downward by acceleration say x meter per second square, then mass m1 will also have the same magnitude of acceleration as x meter per second square in positive x direction, whereas mass m2 will have the same amount of acceleration as x meter per second square in negative y direction. So in this problem, what is the magnitude of tension in the string, that we need to find out, and what is the magnitude of acceleration of the entire system, that we need to find out. How we can find it out? We can find it out if we draw the free body diagram of both the two masses separately, and then let us apply the Dalembert's principle for both the two masses. Then we will be able to find out the magnitude of tension present in the string and the acceleration of the entire system. So first of all, let us draw the free body diagram of both the two masses separately. I hope my white screen is visible to you, and in the Dalembert's principle we are solving in continuation our fifth problem. So let me write over here problem number 5. Okay, so first of all, let us draw the free body diagram of mass m1. So this is my mass m1. This is my mass m1. Okay, what all forces will act on this mass? Firstly, the weight of the block acting vertically downward from its center of gravity. This is the weight of the block m1g. Now you see in the diagram, this mass m1 is kept on rough horizontal surface. So this rough horizontal surface will exert a reaction on this mass m1 block in vertically upward direction. Let that reaction is reaction R. So this is that reaction force R. Again, if you see the diagram, this mass m1 is connected with mass m2 by this string. So this string will exert a tension. Let that tension is denoted by T. So this is the direction of tension exerted by the string. Again, if you see the diagram, mass m1 is kept on the rough horizontal surface, and the mass m1 block is moving in the positive x direction with some acceleration a. Then a frictional force will exert at the point of contact of mass m1 and this horizontal surface, and the direction of that frictional force will be in the direction opposite to the direction of motion of the block. Direction of motion of the block is in positive x direction. So the direction of frictional force at the point of contact for this block of mass m1 will be along negative x direction. So this is the direction of frictional force, and its magnitude is mu coefficient of friction, because in the problem it is given that the coefficient of friction between the block whose mass is m1 and the horizontal rough surface is mu into normal reaction which the horizontal surface is giving to the block in vertically upward direction, that is R. So the magnitude of frictional force will be mu into R. Correct? Is the FBD of mass M1 block is completed? No, it is not completed. Why? We have not introduced the inertia force into picture. Now if we want to stop this moving block, what we need to apply? We need to apply an inertia force in the direction opposite to the direction of motion of the block, and the block is moving. From the question it is clear that the block is moving along positive x direction by acceleration a. So in order to stop this moving block, we need to apply inertia force along negative x direction. So this is the direction of inertia force, and its magnitude will be how much? It is m into a. What is m? M is the mass of the block, and here we are talking about the first block. So mass of the block is m1 into acceleration with which the block is moving, and that acceleration is m1, and that acceleration is a. So the inertia force, let me denote inertia force for this block whose mass is m1 by fi f1. So inertia force f1 is m1 into a, and its direction is in the opposite direction to the direction of motion of the block of mass m1. Similarly, let us draw the free body diagram of block whose mass is m2. Let me see the diagram. The block whose mass is m2 is held vertically. So first of all, let us draw that block first. So this is that block m2. What all forces will act on this block whose mass is m2? The first force is the weight of the block acting vertically downward from its center of gravity, and that is how much? That is m2 into g. Clear? Again, if I see the diagram, block m2 is connected with block m1 by this string, by this vertical string. So this vertical string will exert one tension. Let that tension value is T. So for this block whose mass is m2, tension exerted by the string is T, and this is the direction of tension in the string. Correct? Is any other forces are present? If I see the diagram, is there any other forces present? Or is my FBD is complete? No, my FBD is not complete because I haven't introduced the inertia force into picture. From the diagram it is very much clear. From the diagram it is very much clear with this arrowhead symbol that the block whose mass is m2 is moving vertically downward. So the block whose mass is m2 is moving vertically downward. Then according to Dalembert's principle, if I need to stop this moving block, I need to apply an inertia force in the direction opposite to the direction of motion of the block. So here the direction of inertia force will be along positive y direction, because along negative y direction the block is moving. And what will be the magnitude of inertia force? Let the magnitude of inertia force F2 is equal to mass into acceleration of the block. Mass of the block is m2 into acceleration of the block is a. Now the FBD of both the two blocks are complete. So let me write over here, this is FBD of block, FBD of block whose mass is m1 kg, and this is FBD of block whose mass is m2 kg. Now let us write down the force equilibrium equations for both the two blocks separately. Let us write down force equilibrium equation. Let us write down force equilibrium equation for the first block. So for the first block, if I write summation Fy equal to 0, for the first block, if I write summation Fy equal to 0, what I can write? That is all the forces along, summation of all the forces along y-axis is equal to 0. So I can write R, because this R is acting in positive y direction. This R is acting along positive y direction, so R minus this m1g, because m1g is acting along negative y direction, m1g, no other forces are present along y-axis, so it will be equal to 0. Or I can write R is equal to m1g. Let it be equation number 1. Okay. Similarly, now let us write down. Similarly, let us write down the force equilibrium equation for the same block whose mass is m1 kg along x direction. Along x direction, what I can write? I can write that is summation fx equal to 0, that is all the forces acting along x direction, summation of all the forces acting along x direction is equal to 0. What I can write? I can write tension T acting along positive x direction minus inertia force m1a acting along negative x direction minus frictional force mu r, it is also acting along negative x direction, minus mu r is equal to 0. No other forces are present, so finally the equation will become equal to 0. So this is summation fx equal to 0 for the block whose mass is m1 kg. Similarly, now let us write down summation fx equal to 0 and summation fy equal to 0 for the second block. For the second block. So let us write down so for second block, let me write down summation fy equal to 0. Summation fy equal to 0. What we can write? So we can write this T acting along a positive y direction, tension T T acting along a positive y direction, then plus m2a plus m2a, that is also acting along positive y direction. So let me write plus m2a what else, minus m2g, because m2g is acting in the negative y direction, so I can write minus m2g. Is there any other forces present along y direction for the second block whose mass is m2 kg? No, no other forces are present. So it will be equal to 0. No need to write summation fx equal to 0 for the second block. Why? Because if you see the FBD for the second block, no forces are present along x direction, so no need to write summation fx equal to 0. So let this equation, that is t plus m2a minus m2g equal to 0, is equation number 3. Or we can solve it further. We can solve it further and we can write it down as tension T is equal to m2g we have taken on the right hand side, so minus will become plus, m2a also we have taken it on the right hand side, so ये जो plus m2a है ये बन जाएगा minus m2a, or we can write tension T is equal to m2 को आप कॉमन ले लो, क्या बचेगा, m2 in bracket g minus a, in bracket g minus a. Let this is be equation number, let this is your equation number 2. Correct? Okay. Now what we need to find out in this problem, we need to find out the value of tension T exerted by the string and acceleration of both the two masses, that is acceleration of the entire system A. So let this equation, which equation, this summation fx equal to 0 for the first block, let me write this equation as equation number 2. From equation number we have the value of r, which is how much, m1g. Let us substitute this value of r from equation 1 in equation number 2. What we will get? We will get tension T minus m1a minus m1a minus mu into r. Mu into r is how much from equation number 1? It is m1g. So I can write it as m1g is equal to 0. Or I can write it as tension T is equal to, let us bring both m1a and mu m1g in the right hand side, then what we will get? We will get m1a plus mu times of m1g. Correct? We can take m1 common. If we take m1 common, what we will be left out with? T is equal to m1 is common. In bracket we can write a plus mu g. Clear? Tension T is equal to m1 in bracket a plus mu g. So this is equation number 1, this is equation 2. Okay, let this equation be equation number 3. Let this equation be equation number 3, and this equation is my equation number 4. This equation is my equation number 4. Now if we compare the third and the fourth equation, on the left hand side we have tension T, and on the right hand side in equation number 3 we have m2 into g minus a, and for equation number 4 we have m1 into a plus mu g. So we can equate the equation number 3 and equation number 4 because left hand side of both the two equations are same. So on equating equation number 3 and 4, what we can get, or what we can write? We can write the right hand side of equation number 3 is equal to right hand side of equation number 4. So what we will get? We will get m1 into a plus mu g from equation number 4 is equal to m2 into g minus a, m2 into g minus a from equation number 3. So further let us solve it. Just open the bracket. What we will get? We will get m1a plus m1 into mu g is equal to m2g minus m2 into a. Or we can bring minus m2a in the left hand side. What we will be left out with? We will be left out with m1a plus m2a is equal to m2g. Bring m1 mu g in the right hand side, it will be minus m1 mu g. Okay, further let us solve it. We can take m1 common. So on taking m1 common in bracket we will be, sorry, we can take a common. Sorry, we can take a common. So once you take a common, in bracket you will get m1 plus m2 is equal to, in the right hand side you can take g common. In bracket we will get m2 minus mu times of m1, or we can write acceleration of the entire system or acceleration of both the two masses is equal to g times of m2 minus mu times of m1 upon m1 plus m2 upon m1 plus m2. Now in this expression each and every data is given to you. What is small g? Small g is acceleration due to gravity. Its value is 9.81. What are M1 and M2? M1 and M2 are the masses of the two blocks. In the problem it is given that M1 is 10 kg, M2 is 5 kg. What else? Mu is coefficient of friction. It is also given in the problem. It is how much? It is 0.25. So on substituting all these values in this expression of acceleration A, we will get the magnitude of the acceleration of the system, or the acceleration of both the two masses, which is the first part of the problem. So on substituting all the values, that is values of M1, M2, mu and G as given in the question, finally we are getting the acceleration value as how much? We are getting the acceleration value as 1.635 meter per second square. So this is the first part of the problem, that is with how much acceleration the entire system is moving, or what are the acceleration of both the two masses. Next what we will do is, next we need to find out tension present in the string. Next we need to find out in the same problem tension exerted by the string. How we can find out the tension exerted by the string? We can use this third equation. In third equation we are having tension T is equal to M2 in bracket G minus A. We know each and every value. Once we substitute each and every value, we will get the value of tension exerted by the string. That is tension T is equal to M2. M2 is how much? M2 is 5 kg given in the problem. So we can write 5 in bracket. G is acceleration due to gravity and its value is 9.81 minus small a is acceleration of the entire system, or acceleration of both the two masses. Just now we have found out it is how much? It is 1.635 meter per second square. So let us write the value of acceleration A as how much? It is 1.635. So just solve this expression, you will get the value of tension exerted by the string, and tension exerted by the string is how much? It is 40.875 Newton. 40.875 Newton. This is the second part of the problem, that is you need to find out tension exerted by the string. So tension exerted by the string is 40.875 Newton. Is the problem clear to all of you? So this is the complete solution of this problem. You can see whatever I have solved just now, it is there in the slide also. It is there in the slide also, so you can refer this slide also for the solution of this problem. Okay. Let us solve one more problem in today's class. That problem is this problem. The problem is two blocks of masses M1 and M2 are placed on two inclined planes of elevation θ1 and θ2 and are connected by a string as shown in the figure. Full stop. Find the friction between the blocks. The coefficient of friction between the block and the plane is how much? Mu. Assume M1 equal to 5 kg, M2 equal to 10 kg, θ1 equal to 30 degree, θ2 equal to 60 degree, mu is 0.33. What you need to find out? You need to find out the acceleration of the masses. And the diagram is given to you. Again I am repeating the problem. The problem is two blocks of masses m1 and m2 are placed on two inclined planes of elevation theta 1 and theta 2 and are connected by a common string as shown in the figure. Full stop. Find the acceleration of the masses. Coefficient of friction between the block and the plane is mu. Assume m1 equal to 5 kg, m2 equal to 10 kg, theta 1 is 30 degree, theta 2 is 60 degree, and coefficient of friction mu is how much? It is 0.33. So according to this problem, there are two inclined plane. One inclined plane is AC, another inclined plane is AB. AC is making an angle of theta 1 with the horizontal, and the inclined plane AB is making an angle of theta 2 with the horizontal. On the inclined plane AC, mass m1 is kept, and on the inclined plane AB, block of mass m2 is kept. Both the two blocks are connected by a common string through a pulley at A. What you need to find out? You need to find out the acceleration of both the two masses. Here, if you see the diagram, acceleration of both the two masses will be same. Why same? Because both the two masses are connected by a common string. String is not changed, string is same. दोनों ही मास एक ही स्ट्रिंग से कनेक्ट किया गया है. तो अगर दोनों ही मास एक ही स्ट्रिंग से कनेक्ट किया गया है तो दोनों का जो एक्सेलरेशन होगा वो भी सेम होगा. फाइन. So, and it is also given that the inclined plane AB as well as inclined plane AC is rough, and the coefficient of friction mu value for both the two planes is how much? 0.33. What we need to find out? We need to find out the common acceleration A of the entire system, or acceleration of masses m2 and m1, which is A itself. How we can find out? For that, we need to draw the free body diagram of both the two blocks separately. Before drawing the free body diagram of both the two blocks, first of all we have to find out whether the block M2, whose mass is M2, it is moving down the inclined plane AB or up the inclined plane AB. Similarly, whether the block whose mass is m1 kg, it is moving down the inclined plane AC or up the inclined plane AC. Accordingly, on the basis of the direction of motion, the direction of frictional force and the direction of inertia force will depend. So there is no hard and fast rule. You can assume anything. So here what I am assuming is, let the block whose mass is m2 kg is moving down the inclined plane, then the mass m1, then the block whose mass is m1 will move up the inclined plane. If you take the direction reverse, मान लो आपने ये assume किया कि जो block है जिसका मास m2 है वो ऊपर की तरफ जा रहा है और मूव कर रहा है, और जो ब्लॉक है जिसका मास m1 है वो नीचे की तरफ मूव कर रहा है. You can assume this condition also. Only what will be the change in the answer of acceleration? Say suppose you have got a value in negative. Say suppose acceleration is minus something meter per second square. That means the direction of motion initially which you have chosen, that direction is incorrect. The direction of motion of both the two blocks will be in opposite direction. Say suppose अगर मैंने ये माना कि ब्लॉक m2 जो है वो ऊपर की तरफ मूव कर रहा है एंड ब्लॉक m1 जो है वो नीचे की तरफ मूव कर रहा है, इस एजम्पशन से मान लो मैंने जो एक्सेलरेशन a निकाला उसका आंसर मेरा नेगेटिव में आता है. दैट मीन्स the assumption of direction of motion is wrong. मैंने ये एज्यूम किया था कि जो ब्लॉक जिसका मास m2 kg है वो ऊपर की तरफ मूव कर रहा है, वो ऊपर की तरफ मूव नहीं करेगा बल्कि वो नीचे की तरफ मूव करेगा. Similarly, since my acceleration value is negative, I have assumed that the block whose mass is m1 kg is moving down the inclined plane. My assumption was wrong. The same block m1 now it will move up the inclined plane. This is only the difference. Okay, so let us assume one direction, and that direction is, let us assume that the block whose mass is m2 kg is moving down the inclined plane, and the block whose mass is m1 kg is moving up the inclined plane. So this arrow symbol represent the direction of motion of block whose mass is m2 kg, and this arrowhead represent direction of motion of block whose mass is m1 kg. Okay, now let us draw the free body diagram of both the two blocks separately. So for block of mass m2, this is your block, this is your block whose mass is m2 kg. What all forces will act on this block? The weight of the block acting vertically downward, that is m2 kg. This block is kept on the rough inclined plane AB. So this rough inclined plane AB will give a reaction to this block in vertically upward direction. This is the reaction force of the block, that is R2. Okay. Now by geometry, if this angle is theta 2, we know that this angle is also theta 2. If this angle is theta 2, then this m2g will have two components. One component is m2g cos theta 2 and another component is m2g sin theta 2. Then by geometry, this component will be how much? This component will be m2g cos theta 2, and this component will be how much? This component will be m2g sin theta 2. Since the block is moving down the inclined plane, this is the direction of motion of the block, so frictional force at the contacting point will act in the opposite direction to the direction of motion of the block. So this is the direction of frictional force. What is its magnitude? Its magnitude is coefficient of friction mu into the reaction which the inclined plane AB is giving to the block of mass m2 kg, and that reaction force is R2. So the magnitude of frictional force will be mu R2. Okay. Is the FBD of my block of mass m2 is complete? No. Two forces are still left to show. What are those two forces? One is the tension force exerted by the string, and second one is the inertia force. So since the block of mass m2 is connected with the block of mass m1 by the common string, so let tension exerted by the string is denoted by T. Correct? And since the block of mass m2 is moving down the inclined plane, then according to Dalembert's principle, inertia force will act opposite to the direction of motion of the block. So this is the inertia force, and its magnitude will be mass into acceleration. Which mass? Mass of the second block, that is m2, into acceleration, say A. A is the acceleration with which the second block is moving. Now is my FBD of second block is completed? Yes, now the FBD of second block is completed. In the similar manner, let us draw the FBD of the first block also. So this is the first block. This is the first block whose mass is m1 kg. What all forces are acting on this block? Weight of the block acting vertically downward. This is the weight of the block acting vertically downwards. Its magnitude is m1g. then this block is kept on the rough inclined plane AC. So this rough inclined plane AC will give a reaction to this block in vertically upward direction. This is the reaction force R1. Okay. Now by geometry, if this angle is theta1, then this angle is also theta1. If this angle is theta1, then this m1g will have two components. One component is m1g cos theta1 and another component will be m1g sin theta1. So by geometry, this component will be m1g cos theta1 and this component will be m1g sin theta1. The first block is connected with the second block by a common string. So the string will exert some tension. Let that tension exerted by the string is T. Is the FBD of my first block is completed? No, it is not completed. Why? Because we have not taken into account the inertia force. So in order to take into account the inertia force, what we need to do? We need to see the direction of motion of the first block. So since the second block is moving down the inclined plane, so the first block will move up the inclined plane. If this is the case, then the direction of inertia force will be down the inclined plane. This is the direction of inertia force. And its magnitude is how much? Its magnitude is mass into acceleration. Mass is m1 kg into acceleration of the first block or the entire system, that is A. Now the entire FBD of both the two blocks kept on two rough inclined plane is completed. Sorry, we are left out with one more force, that is the frictional force present at the contacting surface of the first block. Since the first block is moving up the inclined plane, direction of frictional force will be down the inclined plane and its magnitude will be how much? Its magnitude is coefficient of friction mu into normal reaction which the inclined plane AC is giving to the first block, that is R1, mu into R1. So now the FBD of the entire problem is completed. How we can find out the value of acceleration for both the two masses or the common acceleration of the system? For that we need to write down force equilibrium equation for both the two blocks. First of all, let us write down force equilibrium equation for block whose mass is m2 kg. That is, we are writing down summation fx equal to 0 for the second block, that means for this block. Now for this block, let us assume that this is my x axis and this is my y axis. Okay, what we can write down? I can write down, say suppose along this side x is positive and along this side x is negative. So one force I can see is m2 into g sin theta 2 acting in positive x direction. See, m2 into g sin theta 2 minus mu r, because mu r is acting in the negative x direction, minus mu r minus the tension T present in the string, it is also acting along negative x direction, minus tension T. Then minus this m2a, that is inertia force, it is also acting in negative x direction, is equal to 0. Or what you can do is, you can take m2a on the right hand side. If you take it, what you will get? You will get m2g sin theta 2 minus mu r2 minus t is equal to m2a. Let it be equation number 1. Correct? Similarly, we can write down summation fy is also equal to 0 for the second block. that is summation fy equal to 0. What will be summation fy equal to 0 for the second block? We are assuming that this side y is positive and this side y is negative, so it will be r2 acting along positive x direction minus this m2g cos theta 2 acting along negative y direction minus m2g. I am writing cos theta 2 as c theta 2. Cos theta 2 is equal to 0. No other forces are present along y direction, or I can write r2 is equal to m2g cos theta 2, that is m2g cos of theta 2. Let it be equation number 2. Is there any doubt regarding the force equilibrium equation for the second block, that is summation fx equal to 0 and summation fy equal to 0? No doubt. So let it be equation number 2. Now see, from equation number 2 we can substitute the value of r2, that is m2g cos theta 2, in equation number 1. Let us substitute it. So after substituting, what we will get? We will get m2g sin theta 2. See, m2g sin theta 2 minus mu into r2. R2 will be how much? R2 will be m2g cos theta 2. So minus mu in bracket m2g cos theta 2. Then minus t is equal to m2a. Minus t is equal to m2a. Let it be equation number 3. Only what we have done, we have substituted the value of r2, that is m2g cos theta 2, in equation number 1. So once you substitute it, finally you will get the third equation, that is m2g sin theta 2 minus mu times of in bracket m2g cos theta 2 minus t is equal to m2a. Correct? Similarly, let us write down force equilibrium equation for the block of mass m1 kg. So this is that block whose mass is m1 kg, kept on rough inclined plane AC. Now say suppose this is my y direction or y axis, and this is my x direction or x axis. Above y direction, that is along this direction y is positive, along this direction y is negative, then along this direction x is negative, along this direction x is positive. What we will write? We can write, if I write down summation fx equal to 0 for the block whose mass is m1 kg. What I can write down? I can write down plus tension force present in the string T acting along positive x direction, that is T, minus m1g sin theta 1 acting along negative x direction minus m1g sin theta 1, okay, minus this frictional force, it is also acting in negative x direction, so minus mu times of r1 minus the inertia force acting in the direction opposite to direction of motion of the block, and that this inertia force is also acting in negative x direction, so minus m1a. No other forces are present along in x direction, so it will be equal to 0. Finally the equation is T minus m1g sin theta 1 minus mu r1 minus m1a equal to 0, or you can take m1a on the right hand side. When you take it, you will be getting T minus m1g sin theta 1 minus mu r1 is equal to m1a. Let that is equation number 3, that is this equation. Let that is equation number 3, that is this equation. Similarly, we can write down force equilibrium equation along y-axis. If I write down, what I will get? I will get summation Fy is equal to 0 is how much? R1, reaction force R1 acting along positive y direction. So R1 minus M1G cos theta 1 acting in negative y direction. So I can write minus M1G cos of theta 1. No other forces are present in y direction, so it will be equal to 0. Or you can write it down, R1 is equal to M1G cos theta 1. Let it be equation number 4. See, R1 is equal to M1G cos theta 1. Let it be equation number 4. Okay, now again you see from equation number 4 we can substitute the value of R1, which is M1G cos theta 1, in equation number 3 dash. So let us substitute it. What we will get? We will get T minus M1G sin theta 1 minus mu times of R1. R1 is this value, that is in bracket M1G cos theta 1 bracket close is equal to M1. Let it be equation number 5. Okay, now let us compare third and fifth equation. What we need to find out in this problem? We need to find out the acceleration of the system or the acceleration of both the two blocks, which will be same. So in order to find out that acceleration value, what we are doing is we are adding the third equation, that is this equation. We are adding this equation with the fifth equation. Fifth equation is this equation. Let us add it and see what result we get. So on adding equation number 3 and 5, that is LHS of equation number 3 plus LHS of equation number 5 will be equal to RHS of equation number 3 plus RHS of equation number 5. Let us do it. So once you add it, finally what you will get? You will get M2G sin theta 2 minus mu M2G cos theta 2 minus T plus T minus M1G sin theta 1 minus mu M1G cos theta 1 is equal to acceleration of the system A in bracket M1 plus M2. So what we can do? We can cancel out this plus T and minus T. So finally we will be left out with how much will be M2G sin theta 2 minus this M1G sin theta 1 minus this value, that is mu M1G cos theta 1 minus this value, that is mu M2G cos theta 2 is equal to acceleration A in bracket M1 plus M2. That is this equation. Clear? Now again, if you solve it, what you can do is you can take small g, that is acceleration due to gravity, common from the left hand side of the equation. If you take small g common, what you will be left out with? You will be left out with M2 sin theta 2 minus M1 sin theta 1 minus mu M1 cos theta 1 minus mu M2 cos theta 2 bracket close is equal to acceleration A in bracket M1 plus M2. Or I can write acceleration A is equal to this term divided by M1 plus M2. Now in this expression, small g is known to us, that is acceleration due to gravity. Its magnitude is 9.81. M1 and M2 are the masses of the two block. It is given in the problem. M1 is 5 kg, M2 is 10 kg. So in place of M1 and M2 substitute 10 and 5. In bracket M2 is how much? M2 is 10 kg into sine of theta 2. Theta 2 given is how much? Theta 2 given is 60 degree. So sine of 60 degree minus mu. Mu is also given in the problem. That is 0.33. So minus 0.33 cos of theta 2. Cos of theta 2 is how much? Again theta 2 is 60 degree given in the problem. Cos of theta 2 minus M1. M1 is the mass of the first block. It is also given in the problem. That is 5 kg in bracket. Sine of theta 1 plus mu cos theta 1. So sine of theta 1 is how much? 30 degree. It is given in the problem, plus mu is also given in the problem into cos of theta 1. Again theta 1 will be how much? It will be 30 degree given in the problem. So in this expression, which expression? That is in this particular expression. In this particular expression, all the data are given in the problem. M1, M2, theta 1, theta 2 and small g. All these data are given in the problem. Just substitute these values. You will get the value of acceleration of the entire system or acceleration of both the two masses. So on solving this value, we are getting acceleration of the system or acceleration of both the two masses as how much? It is equal to 2.015 meter per second square. This is what it has been asked you in this problem. That is, you need to find out the tension exerted by the string on both the two blocks M1 and M2, and that acceleration is how much? That acceleration is 2.015 meter per second square. I hope this problem is clear to you. You once practice this problem. Okay, whatever problem we have discussed in today's class, just practice these problems. Okay, in the next class we will solve two more problems related to Dalembert's principle, and then after that we will finish off, or we will wrap up this Dalembert's principle portion. Okay then, till then I am ending my lecture over here. Thank you.